Welcome to The Explainer. Today, we're going to pull back the curtain on the incredible science and engineering that gets packed into a piece of gear designed to do the impossible. We're going to trace the journey from a single strand of fiber all the way to a helmet that can stop a bullet. I mean, it's a question that has driven innovation for, well, centuries, right? And the answer has pushed us way beyond simple metal caps and deep into the world of high-tech composite armor, where material science gets really interesting. So to really get a grip on where we are now, we've got to look at how far we've come. The story of the helmet is really a story about the evolution of threats themselves. And you can see the fundamental challenge has completely changed. Ancient armor? That was all about deflecting the sword or absorbing the blow from a club. Today, it's about catching an object that's moving faster than the speed of sound. And that required a total revolution in how we think about materials. All right, let's get into the good stuff. The real magic of modern helmets starts with two amazing types of synthetic fibers, and each one brings something unique to the table. It's really a classic engineering trade-off. On one hand, you've got Kevlar. It's fantastic at absorbing and spreading out energy, which makes it great for stopping shrapnel. On the other hand, you have UHMWPE, which gives you about the same level of protection, but it's a lot lighter. And trust me, if you're wearing this gear all day, that weight difference is an absolute game changer. Okay, so you've got these incredible fabrics, but how in the world do you turn flat sheets of material into a three-dimensional, life-saving helmet? Well, it's a process that's part precision, part brute force. Think of it like a really precise dance. First, everything is cut with absolute precision. The fabric, the films, then they're carefully stacked, layer after layer after layer, 24 layers deep. And that's when the real transformation begins. And this is where things get intense. We're not just weaving here, we are forging a new material. A massive 200-ton press comes down, blasting it with heat and incredible pressure to literally fuse those 24 individual layers into one solid seamless shell. And we're not talking about a little bit of pressure. We're talking over 500 pounds per square inch. That incredible force is what consolidates everything perfectly, squeezing out every last bit of air to create a flawless shell. Because any defect, any tiny bubble in there, could compromise the whole thing. Okay, so the helmet is built. It looks the part, but does it actually work? This is the moment of truth, where rigorous science shows us exactly what happens at the moment of impact. This is absolutely crucial to understand. It's not just about stopping the bullet from going through the helmet. See, all that energy has to go somewhere. And if the inside of the helmet bulges in too much, what they call back face deformation, it can cause an injury just as bad as the projectile itself. So managing that bulge is a huge part of the safety equation. So how do you test for that? Well, there's a super strict protocol. They mount the helmet on a specialized head form, and then it gets shot, not once, but 4 times, from 4 different angles, front, back, left, and right, to make sure it can handle threats from any direction. And wow, this right here just perfectly illustrates the difference. Using a 3D laser scanner, they can map that inner bulge precisely. The red areas show where it deformed the most. Up top, that's the standard helmet. On the bottom, that's one made with a new nanocomposite material. Just looking at it, you can see the pattern of the impact is totally different. And the numbers back up exactly what our eyes are telling us. For the back impact, the standard helmet bulged inward 38.2 millimeters. The new nanocomposite one, only 37.2. Now you might think, 1 millimeter, what's the big deal? Well, when we're talking about something pressing into your skull at high velocity, that 1 millimeter is a huge deal. It can absolutely be the difference between a serious injury and walking away. So what's the secret sauce here? How does it actually work? Well, X-rays of the helmets after impact show us what's going on inside. The energy gets absorbed as the internal layers start to separate from each other. It's called delamination. It's like each of those 24 layers is a safety net, and the bullet's energy gets caught and spread out as it tries to tear through them. So that's the tech of today. But what's coming tomorrow? Where does this science go from here? Because the innovation doesn't stop. The search for lighter, stronger armor is leading scientists down some pretty wild paths. They're looking at things like genetically engineered spider silk. I mean, seriously, which might be even better at absorbing energy than Kevlar. They're developing new metal alloys, and of course, they're pushing the boundaries of nanocomposites even further, tweaking materials at the molecular level. When you think about it, The journey from a simple bronze cap all the way to a nanoparticle-infused composite shell, it just shows you that this innovation never, ever stops. It's always driven by that fundamental need to protect. So the real question isn't if our protection will get better, but just how fast it can adapt to the challenges that are still to come.